The story you're hearing about AI from companies like Anthropic, OpenAI, and XAI are wrong, or at least incomplete. And the massive, expensive data centers they're building and planning aren't needed, at least not most of them. They're talking about spending about $7 trillion by the end of the decade, or 20 times what was spent on the Apollo project after adjusting for inflation. And for what? Is there the revenue to justify these data centers? In 2025, the AI industry pulled in about $20 billion, about 1/40th of just the capex spending by the industry that year. Since then, Anthropic and others have raised the cost to use AI, but not nearly enough to pay even the interest on what they're spending. And at any cost, much above free, CFOs around the world are questioning how much AI makes sense to consume and what's the return on investment. And there are plenty of people talking about the AI bubble and it bursting. So why should decarbonize care? This isn't just about some rich guys becoming less rich. These massive AI data centers are screwing with the path to cleaning up the grid. Dirty, inefficient gas turbines are being deployed. A large AI data center uses as much electricity as New York City, and it's sucking up capital that could be building wind, solar, and battery farms, or researching technologies like fusion that could help us solve the climate crisis. And even if you don't care about the climate or AI, you should care because when bubbles burst, especially large ones like this, it tends to lead to a recession, like the subprime mortgages triggering the global financial meltdown in 2008. And the sooner they burst, the better. When the AI bubble bursts, that doesn't mean AI is going away any more than the dot bomb in 2000 meant the end of e-commerce. If you listen to the financial pundits, you'll hear all about the huge loans and the circular financing. What most are missing is what the future of AI is actually going to look like. And it's not good for the companies building the AI data centers. Stick around to the end if you want to know what the future of AI looks like. The first thing to understand is the difference between cost and price. Currently, the price you pay to use ChatGPT or Claude or any of the other AI tools is subsidized by the investors and banks who are funding the AI companies. Funding is also coming from the profits of legacy technology companies like Google, Amazon, Oracle, and Microsoft. Both Google and Tesla saw negative free cash flow due to their vast spendings on AI. Oracle's bond rating has been downgraded to one step above junk due to its enormous bet on AI data centers for OpenAI. So these data centers are being built not to fill a market need, but are speculative bets by tech bros hoping to be the Jeff Bezos of AI. And so far, the winner looks to be a company that hasn't built a single AI data center, and when they needed an AI model, they paid Google to use theirs. In this video, I'll do something most of the pundits don't. Teach you a few key concepts of AI, but don't worry, no math. I'll also discuss why the current approach is broken and there is a better approach that will be cheaper, easier on the environment, safer for sensitive data, and actually do something more useful than help kids cheat at school or create low-quality YouTube videos. None of these ideas came from me. If you actually listen to the experts who don't work for a company with a vested interest in this failed approach, they're saying the same thing. I have lots of links to these experts in the video description. So today on Decarbonize, we're going to talk about AI, why I think most of the proposed data centers will never be built, and why that's a good thing for everyone, including people who want to use AI. First, some background. It's important that we understand the different kinds of data centers. Here's a nice table I found, which helps with the first division. There's the traditional data centers. When someone says it's in the cloud, that's what's happening in these facilities. Storing family photos, hosting websites and Zoom calls. Netflix and YouTube use these facilities. Your online banking is there. Almost everything you do on the internet other than AI happens at one of these places. They typically use less than 200 megawatts, which isn't nothing. It's like the electricity consumed by a large town or a small city. We can easily build enough traditional data centers to keep everyone happy. When you hear about data centers needing as much energy as a small country, driving up the cost of memory chips, or making NVIDIA the most valuable company in the world, that's an AI data center. The largest data center in the world is Colossus 2, which is owned and operated by xAI, Elon Musk's AI company. It requires 1.563 gigawatts, which is more than the power output of a large nuclear power plant. This is primarily powered by illegally installed, polluting, inefficient gas turbines. I talked about powering data centers like this in a previous video. There are other, even larger data centers in the works. These aren't just bigger, they're different. They have different chips, which are more power hungry, and they're only good at one thing, AI. But there are two types of things done at AI data centers, training and inference. And we need to consider these things separately. Let's start with training an AI model. The more precise term for what OpenAI and the others create is a large language model, but we'll just say AI. To be honest, I've never liked that term, artificial intelligence. I knew someone working on AI back in the late 80s while we were both grad students at MIT, and he said his goal in life was to emulate an intelligent being. I asked him, wouldn't he rather just be smart? And he said, no, a convincing emulation was just as good. So that's what I think of when I hear AI. AI is a mathematical algorithm which we call a model. A model can be described by the number of parameters it has. So what's a parameter? Let's take a simple model, the quadratic equation. That describes a parabola, y equals a plus bx plus cx squared. The values of a, b, and c are parameters. If you change them, you change the shape of your parabola. Training is the process of determining the values of the parameters that give the best output, like fitting a line to data. But an AI model doesn't have 3 or 30 or 300 parameters, and it doesn't take 100 data points for their fitting. An AI model will have hundreds of billions or trillions of parameters, and the creators might scrape every bit of data off the internet as part of the training set. I'm guessing, whether I like it or not, some of my videos and blog posts have been used to train AI. The process of training an AI model is extremely processor and memory intensive. And the chips that were designed to speed graphics for playing computer games, the GPU or graphical processing unit, are good for this kind of work. That's why NVIDIA, which used to make a good living designing and selling graphics card, is now the most valuable company in the world. The bigger your data center, the more data that can be used to train your models and the more parameters you can have in your models. And training with bigger data sets is not always better, not if the data is of low value. As we've all heard, garbage in, garbage out. If you get a bigger data set by adding emails sent by kids, you'll probably get more spelling errors with no additional insight into questions of politics in Africa. So more parameters is not always better, nor is more training data, but it's always more expensive. There are hundreds of AI models that have already been trained, like OpenAI's ChatGPT and Anthropic's Claude. But there are also smaller ones that you can download onto your home computer or even your phone for free. This is an interesting chart, though a bit busy. It's comparing a large number of AI models with a metric called the Massive Multidiscipline Multimodal Understanding and Reasoning Benchmark. It asks a series of 11,500 college-level problems across 6 disciplines and 30 subjects, plus image analysis and expert-level perception and reasoning rooted in deep subject knowledge. It also separates out the proprietary models from the open source ones that you can use for free. There are a couple of things that come out of this graph that are interesting. The models continue to improve, though I wonder if that's because the models are being tuned to do well on this metric. The best of the proprietary models did better than an ensemble of a group of okay human experts, but not yet the best humans. But that looks to be about a year away. The free models are following the same progression as the proprietary ones, but about 9 months behind. The next concept is a token, which is how AI breaks up language. They're typically 4 letters long, but common words will be a single token, as will punctuation. The AI companies charge by the number of tokens you input and they output, around $10 per million tokens, which, as we've discussed above, is a subsidized price. It would cost a couple of bucks to summarize a book. Finally, the context window. This is the number of tokens the model can handle at once. So if you have a conversation with your AI chatbot, they will forget the oldest things in the conversation. And the longer the context window, the more they'll remember. If your model has a small context window, it will quickly become like talking to someone with dementia. A long context window will allow the AI to consider an entire book at once. A model with a large context window is more likely to give you useful results, but will require more computer power and time. Now you know everything to understand inference, using an AI model to answer a query. We type in a query, which is broken into tokens. The tokens are inputted into the AI model to answer your query. Going forward, I want to consider training a model and doing inference separately. Training an AI model will always be done in a large, power and water-hungry data center. But once you've trained it, you can release it into the wild. Each company would need at most one large data center to keep training better models. If you're OpenAI or Anthropic, you host the model in the cloud and you charge to use it. This is the model you hear the most about. They don't need $7 trillion of data centers just for training, but also for inference. But inference doesn't have to be done in the cloud. You can download a model onto your computer and perform inference on the edge. On the edge means at a computer that's close to where the person asking the query is sitting, possibly at their desk or at least in the same building. Downloading an AI model isn't any harder than downloading a word processor or a spreadsheet. And inference on the edge is better for several reasons. Let's start with the one that's going to motivate your company's executives. It's cheaper, much cheaper. There are many frontier quality open source models you can use for free. Currently, all of the AI companies are losing tons of money building the AI data centers to train their models and perform inferences. For instance, OpenAI, the creators of ChatGPT, lost $20.9 billion in 2025, with no end in sight to their losses. If they raised their prices enough to break even, this would quickly become an issue with their users, who will look for ways to get the same value at a lower cost. This has already started, as some of the AI companies have started to cancel all-you-can-eat subscriptions to reduce the bleeding. And this has caused customers to reduce their use of AI, as it's suddenly become a significant expense. So downloading a free model and using it in-house can save money for any significant user of AI. The second issue is energy. There's a very interesting Substack post, link in the description, that I'll be pulling from. But lots of other commentators have made the same point, that the chips that Apple uses in Macs and iPhones are the most efficient hardware for doing inference because of their memory architecture. Other companies like Google are starting to follow Apple's lead, but Apple's on their 6th generation of chips that they designed in-house. So that's a significant head start. What can you do with a Mac? For people who want to run an AI program at home, they can get a Mac Mini for about $1,000 and do inference with some of the smaller open source models, just for the cost of electricity. Or for larger models with a larger context window, you can get a Mac Studio for about $10,000. If you want to run the models with the most parameters and the largest context window, you can string 4 Mac Studios together and go to town. Not only does this Mac cost less, it consumes much less power, about 1/10 as much as doing inference on the chips from NVIDIA. And since it's just a couple of computers, you don't need a big cooling system. In the winter, you don't need to do any cooling at all. Many think that Apple is posed to be the only big tech firm that actually makes money from AI, in spite of them needing to use Google's AI model for Siri and having no AI data center. Actually, maybe because they have no AI data center. The third issue is cybersecurity. Talk to your CTO and legal department about cybersecurity issues with putting everything in the cloud. This has already led to some leaks of sensitive information. But if it runs on a computer in your IT department's cabinet, there's much less risk of a data leak when you use AI. The fourth is that the most valuable AI models will not be the largest, but the most specialized. If I'm running a law firm, I don't want a model that's loaded with medical information. And if I'm a doctor, I don't want a model that's trained on legal documents. These specialized models will be smaller and trained on less data, meaning they're cheaper to create. And because they have fewer parameters, you can perform inference on less power-hungry hardware, maybe just your iPhone. So just taking an appropriate open-source model and running it on your own computer rather than a data center will save money, the environment, reduce your risks of leaking sensitive information, and probably get you a better result than a general-purpose AI like ChatGPT. This, I believe, is the path that AI will follow. More efficient chips running on more efficient models on the edge with open-source models that solve specific, well-defined problems. AI will be common, but not generating a huge amount of profit since the open source models are so good. In this world, there's no money to pay for the large data centers, at least not a lot of them. The losers will be those companies taking on debt to build data centers, many of which will not be needed. And there isn't enough revenue to justify even those that are. The future I'm describing is inevitable. But the question is how much damage will be done in the meantime. How much extra climate-destroying methane will leak into the environment? How many neighborhoods will have to suffer from these facilities' air pollution? And how much money will be wasted overbuilding these monstrously expensive facilities? How many retirement funds will be decimated by this pointless race to build something that has no return on investment? If it wasn't obvious yet, I'm not a financial advisor, so take what you've learned here and do with it as you will. Let me know your thoughts on AI in the comments. Do you think there's a path to Oracle paying back their loans and OpenAI making a profit? If you learned something, I recommend liking and subscribing, and you can support the channel by buying me a pint or a YouTube thanks. Maybe you want to watch my video on powering data centers. And please forward this video to everyone you know who thinks AI is gunning for their job.